Hey guys, welcome to day 77 of Codeforces Everyday until GM. So last time we were unable to solve this problem, arraycraft, but I was able to ask some people and think about it a little bit more, and I think I got a solution for this project, or for this question. I definitely do, but I just wanted to show y'all and prove it. And yeah. Oh, by the way, I've been talking to some of my higher rated friends about like question review and getting like the maximum value out of questions. Like this is one of the questions that like since I struggled a lot with, I've spent a lot of time on that I should probably try my best to extract maximum value out of these questions. And I have a number of questions bookmarked like this, if y'all remember some of them that I've struggled on back in the day. Or back in the day, I say that, but like it means like 4 months ago when I started. I got a whole list, right? Um, some of y'all might remember stuff like yet another mechs problem, war strategy, boredom evens, 1500 question. I even have some like 800 rated that are had a tricky idea that I wasn't used to, or like maybe like President's Office, where it's like this was a 2D array question. It was like completely on implementation, where I struggled. Right. Um, I want to go ahead and like start maybe a side series. I'll probably put it in the same playlist as all my other Codeforces stuff, but like a question of me doing an in-depth dive onto these kinds of questions, with stuff like my initial intuition, my thought process, and then the actual solve. What other resources can I look at? Stuff like that. Maybe even stuff like a visual aid, a visual example, whatever I can do to like fully understand these questions and to help y'all understand these questions, because a lot of these Codeforces questions, they're difficult, but they don't really have visual solutions. They don't really have video solutions. The editorials are like just proofs. Like some of them are not well written. Some of them are very math heavy, and after you read it, you're just like, what am I reading? What does this mean? Right. So that should help y'all while solving these problems to like understand these problems, and it should help me to just really understand exactly what my code is doing, exactly how I should be thinking through these problems as well. So yeah, look forward to that. I think I'll be releasing a few videos, just covering like the first few. Like I'll always review them on my own first and make sure I understand it before I give y'all anything. And I have been doing the shorts on these. Like some of these I've done shorts on before, but those are kind of just like for engagement to the channel. Um, so yeah, I just wanted to put out better quality videos, not just rely on like a short review. But yeah. All right, back to this question, arraycraft. So what this question is basically saying is we need to create a array, um, and we can like we need to create an array of ones and negative ones. Basically, we are given three integers, n, which is the length of the array, and x and y, which is the index where, so x is the index where the maximum prefix should be, and then y is the index of where the when the maximum suffix should be. So essentially it's just saying when you make a prefix array, x should be the largest number you can make. X should be the index of the largest number you can make. And then same for suffix, right? So I struggled a lot on this question. I was thinking about some sort of cancellation. Cancel. What am I trying to say? Essentially, I'll just show you an example. Y'all may remember me drawing something like, I don't know, 1, 2, 3, 4 for the case 4, 4, 3. And doing something like how can we maximize the prefix? Well, if we put 4 fours or 4 ones, then our maximum would be on index 4, right? Now, how can we maximize the suffix? If we did something like 1, 1, 1, negative 1, or like at index 3, so 1, 1, negative 1, then it'll be maximized here, and we'll have 2 negative 1s. And then we end up with something like negative, we like see, if there's a negative 1, then we just keep it. 1, 1. And this did all right. This was able to get to test case 2, or test 2, but it didn't work completely. And there's a reason for this. Because if we just have a... Okay, so I think in order to explain why this doesn't work, I have to explain the actual solution first. And the idea is if you have like a ton of numbers, let's just draw this in like a box form. And then y is always going to be smaller than x, right? From this right here, x is greater than y. So we will have some y over here, and then some x over here, right? And in order to get the maximum, like what we should do is we should fill like all the boxes in between with ones, and then the side boxes, like next to these, should be negative 1. Why? Because then, say we're summing all this, and then we're only adding ones here, so the prefix sum can only increase during this one period, and then it hits this negative 1. So that means when it's here, the prefix sum must be less than the maximum, because this would be the highest, and then this would be one under the highest. And then what can we do from now on? Well, we can alternate ones and negative ones, because then this way we guarantee, oh, this might be the highest again, but it's never going to exceed the highest. And for prefix, we take the smallest index. And since this shows up first, it's the smallest index. And yeah, again, afterwards, even if we have more ones and negative ones, you'll see that this will be like 1 under, this will be 1 above, this will be 1 under again, etc., etc. And the same for the other side. Let's just do this. And so if we're summing the suffixes, then since we've already filled this out, I'll just go ahead and use it. We'll see, oh, we might go down 1, we might go back up 1, go down 1. This doesn't really do anything. But once we start adding stuff again, we can only go up again. So then this will be our highest suffix. And then we go down 1, so this must be 1 under our highest. And then for the rest of it, we just fill it out with ones and negative ones, because then this will be our highest again, and this will be our 1 under, and etc., etc., etc. So for suffix, we want the largest index that satisfies. So since this is the largest index, because right, this could be the highest as well, since this is the largest index, we take this one. So that's why this works. Now, why does this not work? Because this will end up with a case where the highest, or like where we will end up with a highest, but we may have multiple instances of a highest. And what this will do is it will force you to choose the first instance of the highest. So for example, if we were doing prefixes, instead of choosing this one, well, it might actually work for prefixes, but it fails for suffixes. Instead of choosing this one, since this is the highest, right, we will actually choose this one since it's earlier in the array. So that was I think that's why my code yesterday was failing. But yeah. Now, you may ask, why can't we just fill these sides with ones? And that's because it will decrease the maximum max that we can have uh, in our prefix. So if we just like kind of do a small little simulation and do like something like this, then we can see that we'll have -3 and then like -1, -2, -3, and then -2, -1, 0, 1, and then negative or 0, -1, -2, and uh satisfies. I think for this case it might actually just be fine. Well, no, it's not fine because it. Okay, these are actually supposed to be like these are actually supposed to be like pseudo ones as well. I just used them to mark the indices, but if these were ones, you'd have -2, -1, 0, 1, 2, 3. Wait, -3, -2, 1, 0, 1, 2, 3, -2. -1 or 3, 2, 1, 0. I low-key think that for this case it just works. Let me think. 1, -2, -3, -2, 1, 0. So on X it should be the position of the maximum prefix. This might just be a bad example, but the idea is if you have more -1s, um, if you have the right example, it will shift the location of the maximum so that it's not like directly on the given X. I'm trying to think. Or even if it works for prefix, it might not work for suffix. Something along those lines. But okay, so let's just start implementing our solution. So in order to do this, we can start off with like a temporary okay, let's define a two-parent first. And we can start off with a temporary variable, set it to -1, and we'll have like kind of three sections, right? A left, right, and middle section. We can always, let's just do the middle section first because it's easiest. It's basically just okay, we fill it with ones and then times, we go from y minus x, right? That should be this 0. Oh, first things first, let's just 0 index these things. So yeah, let's just double check this is working. Print and y. Oh, it should be x minus y. One. Okay, yeah, 1, 1, and then there should be 4 ones. This is correct. From 0, 1, 2, 3. 0, 1, 2, 3. I think I need a +1 here, actually. Let me think. 2, 1. So it's like this. Yeah, I think I need a +1. And then we need to alternate negative ones and ones on the left and right side of the middle, right? So we can start with a -1 character. I probably don't even need a 2 print, now that I think about it. We can start with a -1 character, and then let's instead of 2 print, let's define the left. For I in range y, what we should do is append temp and then multiply temp by -1. And then, so for the left side, what this will create is like a chain of -1, 1, -1, 1, -1, etc., until m. So what we actually need to do is we need to reverse this so that like we make sure the -1 is next to m. Because if we had -1, 1, -1, 1, and then our m is 1, 1, 1, 1, then we'll have two ones touching, and that's no good. We want the -1 touching. So let's do L equals L reversed. And then we already have m. And then to calculate the right side, we can do the exact same thing just without the reverse. And we switch out the y for n minus x minus 1, because if y'all take a look, we start from n, which is over here, minus the x index. And so that covers all of this stuff. And this x index is going to be a 1, so we just do -1. Then we are append. We still have a temp. And then at the end, we can just print star L plus R plus F plus L plus M plus R. There we go. And okay, this is almost right. I think I have an extra input somewhere. Let me double check. L plus M plus R 1 times x minus y plus 1, that's correct. And minus x. Huh, what is it? We're appending an extra -1 in front. So it's something with this that's wrong. 1 temp times equals -1. Now dot append temp y range y. Oh, it's this. Don't know why I did 0. We should be minus equals 1. And there we go. If I submit this, it should work. Hello? Is my extension working? Okay, I'll just submit it manually. And there we go. So that's kind of how this question works. I'll definitely do a review thing on this question, as I was talking about earlier. I don't know when I'll do it. Maybe I'll do it a few months from now when I kind of forget the question and need to learn it. But yeah, I'll have like better explanations for everything, and I'll have a whole script for it so that y'all fully understand what's going on. I guess today is kind of just like a preview of like the style of video. Um, Today's still gonna be like a just me solving problems type of video, but I wanted to like kind of try out this idea with this question in specific. There's definitely things I need to work on, and yeah, let me know in the comments below what I can improve on, at least explaining wise. But okay, how long did that take? 20 minutes? Let's do more problems. Make almost equal with mod. If we're able to do this question fast, I kind of want to try a harder question today. Just because I've been trying to practice, but why is my thing just not working? My extension. This kind of pisses me off. Do I already have this question? 1909 B? I don't have it, right? Hello? Shit, do I need to relaunch my VS Code? There we go. And okay, it was tripping balls. Oh. Rating 1200. That's too much. And then copy this, paste. Given an array of distinct positive integers, you have to do the following operation exactly once. Solar system. Wait, isn't this guy an art core? Dude, I low-key listened to this person. Right? He made Ascension to Heaven, stuff like that. Am I tripping? Why was this in Codeforces? Wait. Is this a rabbit hole? Is this even the same guy I'm thinking of? Oh, this has to be him. Wait. Wait, is this guy right? Solar system. Solar storm. That's crazy. Why is this in Codeforces? Yeah, this guy's good. I like his music. You're given an array A1, A2 to AN of distinct positive integers. You have to do the following operation exactly once. Choose a positive integer k for each I from 1 to n. Replace AI with AI mod k. Okay, find the value of k such that k is between these, and then the array contains exactly two distinct values at the end of the operation. It can be shown that under the constraints, k always exists, multiple solutions for any. Okay, so what is it saying? You have an array of distinct integers. Do the following operation exactly once. Choose k for each I from 1 to n. Replace ai with ai mod k. So replace the value for each index from 1 to n. Replace the value with the value mod k. All right. I like the wording for this question, at least. It's not too complicated. So let's think about it. In the first test case, you can choose k equals 7. The array becomes 8 mod 7, which is 1. 15 mod 7 is 1. 22 mod 7, is 1, 30 mod 7 is 2, which is 2 distinct values. Okay. So can't we just use exactly 2? Does it have to be exactly 2? Exactly 2. Okay, so my first thought is using mod 2, right? Because you can either have, if it's even and odd, you can have all 2s, and or like if you have at least one even and at least one odd, then you'll have 2 distinct, right? Like it's either going to be 0 or 1 values, right? So like that would work for this case, that wouldn't work for this case, that would work for this case, that wouldn't work for this case. So the only cases where it wouldn't work if it just has all evens, all odds, which is no good. So this is not the answer. I wonder, if it's all even, what do we do? 2 distinct. 2 distinct. Um, hmm. Why 7? How did they get 7 from the first? How did they get 7? 8 would be 1. But which one is different? Mod 30. 30 is 2. Everything else is 1. Why? Why can you confidently choose 7 here? Alright. Bit masks. Constructive algos, math number theory. Bit masks. I could see how bit masks might help. But okay, let's just turn all these into binary real quick. 8 is 1000. 15, 22, 15. 1, 1, 1, 1, I believe. And then 22 is 0. I'm just pulling up a calculator. 0, 1, 1, 0, 1. And then we got 30, 1, 1, 1, 1, 0. And then 7 is 1, 1, 1. So how can we pick 7? Is it the first indexed where... No. That's not it. Plus. Hmm. Second test case, you can choose exactly. You can choose k equals 30. 0 and 8. Choosing 10 would also be valid. The last test case, you could choose quite literally anything, right? I'm gonna run to the restroom real quick, guys. Alrighty, quick toilet run. Didn't gain any insight. Bitwise. How does Bitwise help? What happens if you, like... What is modulo? What is division? What does division look like bitwise? Like 8 divided by 7. It's just 1. 30 divided by 7 is 4. 1, 0, 0. With a remainder of 2. 1 with a remainder of 1. I don't really like this. I think my odd and even thing does much better so far. It's kind of hard to see a correlation in anything. Okay, say we explicitly choose like 1 and 2 as our target. Then that means... Okay, say we explicitly choose... We explicitly choose 0 as one of our numbers. No, that won't work. So then we have to choose k equals k, or k equals 8, and then we get stuff like 7, 5. Yeah, that won't work. It can be shown that under the constraints, at least one such k always exists. So if I have 1, 2, 3, 4, the correct answer is just 2, right? If I have 1, 3, 5, 1, 3, 5, 7. Since we have a 1 mod anything except 1 is just 1, so one of our numbers has to be 1. We can't choose 2 because they would all be 1. Can we choose 3? Yes. No. Because then this would be 0. And this would be 2, 1. Can we choose 4? No, because this would be 3 and then 1. Wait, we can't choose 4. Why can't we choose 4? One, 3, 5, 7, 4. Where's my earlier stuff? What's gone? Drover. 8, 15, 22, 30. This is 7. Why? What's with the breakpoint? What pattern is there? One, 3, 1, 3. 4, 1, 3, 3, 1. Odd 4 is 1. Yeah, 1. 1. Hmm. 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 Think. What do these have in common? 0, 0, 1, 2, 3, 1, 2. 1, 3, 1, 3. But look at it. 1, 3, 1, 3. 1112. This is two to the 3. What's his last number? 30. 8 plus 4 plus 2 plus nothing. And 7 is 1 plus 2 plus 4. $14. One is 4. 10 is 2. Huh. What are we actually looking for here? I don't get it, guys. I don't see a pattern. Maybe this is just the wrong way to think about it. Like, maybe it's not bitwise. It's a bitwise tag, but maybe you don't need it. Okay, so what was I thinking about originally? 2 works for all cases except if the arrays are all even or all odd. So basically, we can use this strategy, but we'll have 2 edge cases. We just have to handle the edge cases. So what number? We would have to use a different number for all even, all odd, right? Mm. What if it's all even? Two, 4, 6, 8. We can choose 4 again, right? There's 2, 0, 2, 0. Ten. Just 2. 12. 0. What if we skipped some numbers? Like we didn't have 10. Didn't have 6. Didn't have 2. We can't choose 4 anymore. So we choose 8, right? This would be 0, this would be 4, this would be 4. Say we had 14. We would simply choose 4. So we had 14, 18. If we choose 4, 6, 2, it would work. Okay. So does 4 just... No, because this case where we pick 8, right? Was it this case? Yeah, we pick 8. What about odds? 1, 3, 5, 7, 9. But we remove 7 and 3. Then we pick 5. No, then we pick... If we were to pick 4, we'd get 1, 1, 1, which is not good. One, 5, 9. What would we pick? 1, 5, 9. One of our numbers has to be 1, which means we would have to pick 7 or 4. 4 doesn't work. We get 1, 1, 1. So we would have to pick 7. Get 1, 5, 2. That doesn't work. 5 mod 7 is 5. I can't pick 7. Wow, I haven't even taken an input for this question. T N A. Hmm. No, it's this. Then we have cases for these. Just how to handle. Picked K is 7. Hmm. What actually happens if I choose an all even array? Like, say I choose this, and I choose 2. Choose this, and I choose 2. Okay. Zeros and ones. if we used 4? If we used 4, okay. Though, if we used 4, 0 to 2. Two, 2. Why is it not all 0? For 4. 4 would be completely valid for this case. Four. 2, 4. Okay, wait. This is a bum case. This works for this. This is the case I should be looking at. 60, 90. Actually, I don't even think I should be looking at this case. This case is too big. But let's look at it because I have nothing better to look at. 60, 90, 98, 120, 308. Okay, what if I mod to all of this stuff? All 0, as expected. What if I mod 4? Okay, this is also expected. So for evens, it seems I can just use 2 or 4. Kind of want to try for this case. It's all 0. It's all 0. Okay. 4, 6. 6 works. 8's all 0. 10. Doesn't work. 12. Should work. Yes. Okay. What the fuck does 6 work? Why the fuck does 6 work here? One, 2, 7, 11, 16. 1, 2, 7, 11, 16. So could I just use... No, that wouldn't be a good idea. Would it? No, because if one of these had a random 1, and it didn't random 1, or like random 2, wouldn't even fucking matter. Why? Why does 6 work? Why does 6 work? So now I want to try for an all odd. Like, what if I just add 1 to all these? Four works. 6 also works. 8 doesn't work. 4 works. I only see my goals, I don't believe in failure. 6 works. So is it just like... It's some multiple of 2. The answer is always some multiple of 2. It's 2 times... What? That would be so slow. Okay, say I was doing this. 6 works, but 8 doesn't work. 16 works. Okay. That actually does mean something to me. "16 works. Wait, what was I trying earlier? 2, 4, 6, okay, 6, 8. 2, 4, 8, 16 works. Why is this the case? Why? What does 16 have? 16 is 4 squared. 16 is 2 to the 4. What is 16 in binary? Okay. That doesn't tell me anything. I only see my goals, I don't believe in failure. This doesn't mean anything to me. What works for this? Was it 4? Yes. Four is 2 bits. 10. 16 is 4 bits. Or no, 16. What is 16 again? 16 is 5 bits. No, isn't 4 3 bits? Yeah. 3. Okay. But then that would be 0. Yeah, some of them would be 0. Some of them would be 1. Could also have 3. Right? If it was 1 1. Oh. And this. Yeah, there's 3 distinct ones. What is 11001. So it's non-inclusive? Okay, I have a theory. What's the... Let's add 1 to all these again. 4. 4 works for this. Why? Because what's the bounds of this question? The bounds of this question is 10 to the 17. K is 10 to the 18. We have 1 second. I think O of n operation. So okay, so this is why we need bits, I think, because I think this simplifies it to, okay, what is 10 to the 18? This is like one of those, like, you just try type of questions. It's 2, okay, what is 2 to the, what is 2 to the 20? That's 10 to the 1, 2, 3, 4, 5, too small. 10 to the 50 is 10, 15 zeros, which is still too small. 10 to the 60, or 2 to the 60 is 18. It's like 1.1. It's like, okay. It's slightly smaller. Let's just use 60, I don't care. 2 to the 60. So, I think we just look at this is 4, right? 4 worked. This one's 16 worked. So we just look. We just check each bit. And we stop at 2 distinct. Yes. I think so. We track 2 things. Okay, yeah. I think this doesn't matter. This doesn't even matter. I don't have to check this. I basically just look at each bit and I check. Okay. range 60. I don't even need this, I don't think. Is this gonna be fast enough? Because I have to check 60 columns. Check if all of them are the same. I have 1 second to do this. This is gonna be slow, right? Alright, let's just code it and see. Fall in and 1 is equal to bits for in A. This is gonna be too slow. I don't even think I outputted the right thing. Received output 1. I have an I. Don't need counter, I can just use I. Sure, shit doesn't work. No, 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 no. It's supposed to be like this. Start at 2. Three. It's 2 to the 3. Is it? We have 1. That's just 2. It's 2 to the 1. It's 2 to the I. We should start at 1 at least. And then print 2 to the I. Right? Two. Sorry. This worked for some reason. Oh, no output. 1, 2. It should be 4. Expected output 4. Here. We made it here. Our bit is all 1. We check the second bit. Our target is 0. We made it. It's all 0? Am I bit shifting correctly? Can I print A after the bit shift? How do I... Bin A. It's Jover. What is this doing? What is this doing? Am I shifting the wrong way? This. Okay, we're cooking. There we go, that works. Two, 4, 2, 16, 2. Just double check all this. It's this one, so it's 2 to the 1. This one, 2 to the 2, 4. This one, 2 to the 1. One, 2, 3, 4. So 2 to the 4, 16. This one is 2 to the 1, 2. Okay, this works. This might just be way too slow. This is... what time complexity is this? 60 times... n. I don't think this is gonna work. I mean, submit it and try it. Maybe too slow. We have 1 second. Oh, we got it. Wow, this was fast enough. What's the time complexity for this? Yeah, we ignore test cases and then input yes. This is O1 is correct. All function is O of n. Yes. This check is O of n. $59. Okay. Yeah, I see. Well, we got it. This question was hard. Fuck. How long did this take me? About an hour, 10 minutes. I'm not really satisfied with that. But the recording has been an hour, 40 minutes long now. Definitely a question for review. How would I, okay, what is the intuition about, like, I'm trying to think, just start from fresh, how would I get here faster next time? What did I do? First we check even odd, right? So now we have to deal with all even, all odd cases. Like, I got there pretty quickly. Just after that, how do I know to mess with bits? Because of the tag, but if I didn't see the tag, how would I know? You know? If I didn't see the tag, what would I have done? Probably would have just played with modulos for a little bit. Powers of 2. I feel like I would get to powers of 2 somehow. How, though? Like, maybe I would just start trying modulos on, like, fully even, fully odds to... But I feel like I would get stuck, because I would try 6 and it would work. And I would have no idea why 6 would work. And maybe I would abandon power of 2s. I feel like I definitely would try 2s. Like, maybe I would try 3 and then 4. And then... I don't know. I'm gonna have to ask one of my stronger rated friends for their intuition on this question. This was a little bit insane. Alright. If y'all enjoyed this video, be sure to like and subscribe. I will see y'all guys tomorrow. Bye.